Good morning, everybody. How are you today?
We're doing good.
Good. There's somebody in the waiting room who's not allowed in because that person's name is not on my roster, and I'm tired of playing this game. So if you know who that person is that's waiting,
Good morning, teachers.
please tell them to correct their name.
This very brief announcement. I wanted to reiterate the issue we had with the ACT school day testing. We will be reordering assessments for all of those students, as the timing code was not the accurate timing code. We have notified the district, as well as other schools have notified the district, and we will be testing all of those students on October 20th through the 23rd.
Of course.
All students who took that test, that's our seniors, who have not passed the FSA, will be taking that test again during the week of October 20th through the 23rd. So if you have any seniors who have not passed the FSA, please encourage them to return on October 20th. None of the assessments that we took this week will be scored or counted. So if they do not come on the 20th, they will not have an opportunity to pass on the ACT. So please relay that information to the students. We'll see them next week for the SAT school day on Wednesday, October 14th, as well as our sophomores and juniors for the PSAT. For our juniors who are concerned about the virus, you do have an opportunity to submit an alternate assessment request. That's only for the juniors for national merit participation. So please wait for announcements on that. We will send a parent link home as well as the request so that the parents are aware. That's only for juniors. Thank you and have a great day.
Okay, hopefully that's the last of the announcements. I'm going to put up a Bellwork real quick. And you guys will do the Bellwork while I finish taking attendance.
Also, teachers, we are
It never
continuing
ends.
the FSA and the
It
EOC
never
testing.
ends. I
If
can't
you
deal
did
with
not
it.
check your mailboxes for the passes, the green testing passes, please send someone down to the
Can't take
guidance office so that we can give those to you. And at this time, please distribute your green testing passes so that students can get to their location. Thank you.
Maybe that will be the last of them. I bet you guys don't miss the announcements every day. I can barely take them. Cody is here. Okay, Rohit is absent. James is here. Rohan is here. Absent, absent. Mathangi is here. Huh. Tardy. Let's see, Scotty's not here. Scotty. Nope. And Shri is not here. Hey, anybody get an answer yet?
I got D.
Got D. Anybody else get D or another answer? So this is from an AP Calculus test. So all of these Bellworks are from prior exam questions. And what I want you to notice when you look at the graph is that this is a function that's increasing. It's concave down over its whole domain, okay? And this word twice differentiable just means you can take two derivatives of it. So we want to put these things in ascending order. So which of the following is true? Well, what I know is that f of 1 is 0, right? And what I know is that f prime of 1, if I were to draw a tangent line to that point there, it's a positive number, like probably a 1 or something like that. And then the other thing I know is that the second derivative has to be negative because this thing is concave down. So you said D, is that right?
Yeah.
Okay. So the second derivative is definitely a negative number, right? It has to be negative. We don't know what it is. We don't care. But the second derivative is negative. The first derivative is positive 1-ish. And f of 1 is 0. So is D correct? Yeah. Right? If this has a slope of, if f prime has a slope of 1, then that's bigger than f of 1, which is 0. So it says the negative number is less than f of 1, which is 0, which is less than the derivative at x equals to 1, which is about a 1. Is everybody okay with that?
Yeah.
Okay, good. If there are any questions, let me know. And before we go to homework questions, speaking of questions, we're going to wrap up section 4.1, the basic derivative rules, which I hope you had fun with. And we're going to cover two sections today. And before your eyes pop out of your head, 4.2 is a very quick, I mean, it's super easy. All you have to do is you only have to memorize one thing in the whole section. So this is super quick and super easy here. Derivatives of exponential functions. And then section 4.3 will be a little more challenging because now you're going to have to find derivatives of products and quotients. So with that said, are there any questions on the homework? Does anybody have a homework question? So I know we have number 23 because I was asked for number 23. Was that the number 23? Okay. Were there any other questions on section 4.1 homework?
21.
21. So we got 21, 23. Anybody else? Going once, going twice.
19B.
19B. All right, so let me share my iPad screen and get some virtual paper here. And make sure it shows up. There it goes. And we're, oh, not that. Hey, what's going on here? Good notes. All right, so let me just do a new thing here. Got some fresh paper. And come on. Okay, what's going on? Oh, it's going this way. Okay. All right, so in number 19, part B, it says find the equation of a tangent line to the graph of the function at the indicated point. So f of x was x cubed plus x, and the point that was given was -1, -2, right? So what you need to do, you have a point, you have to find the slope of the tangent line if you want the equation of the tangent line. So to find the slope of the tangent line, you take the derivative. So the derivative of the first term, x cubed, is 3x squared. Is that okay? And the derivative of the second term is 1. Is that all right? So to find the numerical slope, then what I have to do is I have to plug in the x value or the x coordinate of the point that's given into here. I have to evaluate this derivative at x equals -1, which would be 3 + 1 or 4. So this is the slope of your tangent line. This is the point. And now you can use point slope formula to find the equation. x naught. So I guess it'd be y plus 2 is equal to 4 times x plus 1. And you can simplify it into y equals mx plus b if you want to, or just leave it like that. Is that okay? Did that help? Whoever asked me this question? Hello? All right, well, that's how you do it. Number 21, you are given the particle of a motion whose position is given by, now I'm going to show you how to write these. This is t cubed over 3 minus 9t squared over 2 plus 14t minus 6. And if that bothers you, just know that this is the same as 1/3 t cubed minus 1/2, well, 9/2. So what I'm doing is I'm pulling out this 9 over 2, constant multiple. So 9/2 t squared plus 14t minus 6. All right. So in other words, 1/3 times t cubed is just t cubed over 3 if you want to write it like that. So you can always kind of pull those out to the side. Now, if we take the derivative of position, that's going to give us velocity. So the derivative of the first term is 3 over 3t squared, or t squared, because the 3's cancel, minus, if I take the derivative of the second term and I bring the 2 down, well, the 2 on top is going to cancel with the 2 on the bottom, so it's minus 9t plus 14. Is that okay? Are there any questions with what I did there? So what I have now is the velocity function. And it says, at what time from t equals 0 to t equals to 10? So in the interval from 0 to 10, when is the particle at rest? Well, if I know what the velocity function is, and I want to know when a particle's at rest, what do I know about velocity?
It has to equal 0.
Yeah, so all we're going to do is we're going to factor this or set it equal to 0 and try and factor it and solve for t. So this actually factors to t minus 7 times t minus 2. So we get t equals 2 and 7. So there are 2 places in the interval from 0 to 10 for which this particle is at rest, at time equals to 2 and at time equals to 7. Is that okay? I love that you guys ask me questions, and then when I ask you if you're good with it, you don't answer back. And now on number 23, it says determine if the function is increasing or decreasing at the point. So in A, you have f of x is equal to x to the 1/2 plus 2x minus 13. At the point, you can call it c equals to 4, x equals to 4, it doesn't matter. So when a function's increasing, we know that the derivative has to be positive. And when a function is decreasing, we know that the derivative has to be negative. So what I'm interested in is finding the derivative, setting it equal to 0, and then finding the sign of the derivative about its critical numbers. So let's take the derivative first. The derivative is 1/2 x to the minus 1/2 plus 2. And to clean this up, this is 1 over 2 root x plus 2. Okay? So don't forget that these rational expressions, so I'm just using a random one here, the denominator of the rational exponent is the index of the radical, and the variable raised to the numerator of that rational exponent goes under the radical or inside. So we can always convert from rational to radical and vice versa anytime we need to. This is going to be easier to compute without a calculator. And so what I'm going to do now is I want to evaluate this derivative at x is equal to 4. But before I do that, what I want to do, well, I don't know if they, because this is actually in the next chapter, increasing, decreasing function. So I could set this derivative equal to 0, solve for x, get the critical numbers, plot them on a line, and figure it out. But let's see, f prime of 4 is equal to 1 over 2 root 4 plus 2, which is 1/4 plus 2, or 9/4, and that's a positive number, okay? And if f prime is positive at that point, what do I know about the function? Neha, what's the function doing? Javier, what's the function doing? Antonio, what's the function doing?
Increasing.
It's increasing, that's right. Okay, so I can say that the function's increasing at that point. And then in part B, we have f of x is equal to x to the -2 minus 3x plus 15. And we're curious at x or c equals to 1. So again, we're going to take the derivative. So that's going to be negative 2x to the -3 minus 3. That's our derivative. And we could rewrite this as negative 2 over x cubed minus 3 to make it a little more friendly to compute. And now if I evaluate that derivative at that point, it's going to be negative 2 over 1 minus 3. Well, a negative plus another negative is a negative, so I don't care what the number is. I just want to know what the sign is. And since f prime of 1 is negatively valued, then that implies that f will be decreasing. Is everybody okay with that?
Miss
Yeah.
Wilson,
Uh-huh.
Naomi's Zoom crashed and she's waiting in the waiting room. She's asking to let her in.
Got it. So any other questions about derivatives? So on Tuesday, what you guys can expect, and I don't care who's testing and who's not, because I'm over it. You're going to have a quick quiz on taking derivatives. Again, it will be timed. So you're going to be under a time crunch, that kind of pressure. But I'm going to give you 5, 6 functions, and you're going to be asked to take the derivative in a very short amount of time. Just the basic ones, not what you learned today. Okay? So you will have a quiz on Tuesday for day 1. Blocks 1 and 3. But as you do section 4.2 and 4.3, you'll become even more proficient in those basic rules, because you always need to use the basic rules at some point. So even though I won't be quizzing you on the 4.2, 4.3 stuff, although maybe I'll give you a bonus because 4.2 is so easy, then, you know, we'll see how. You're not going to have to do the new stuff. Just remember that. Okay. So let me go into Canvas. Well, actually, let me see. I think I have 4.2 here somewhere. Let me see. 4.3. There's too many things in here. I keep saying I'm going to delete them all, and I never do. So yeah, let me go into Canvas because that'll be the easiest way to do it. And I will pull up 4.3 and 4.4 and put them in to GoodNotes. Oh, that's nice. There's nothing. I have no classes. Here we go. I use block 3s. So I'm going to upload 4.2. Come on. Upload to GoodNotes as a new document. And then I'm going to go back here and I'm going to do 4.3. And we're going to learn some more derivative rules today. And as you can imagine, as the functions become more complex, the rules become a little more complex. But what you're going to learn today is not that big of a deal at all. All right, so let's do 4.2 first. And here we go. So 4.2 is differentiating the exponential functions. If you think of, something like f of x equals 2 to the x, f of x equals 5 to the x, what you have is a base, a numerical base raised to a varying power. And all of them look like this, including e to the x. If we had the function e to the x, e is a number, right? So all of those graphs look just like this, okay? And we can, shift them, stretch them, whatever. But the idea is when we have a numerical base, our base has to be bigger than 1. So in other words, you're not going to see 1 to the x. That is something special, but it's not for this class. It's way beyond the scope of this class. So your numbers are going to be greater than 1. And the idea is that we need to find the rate of change over the entire domain of the function, over the entire domain. When we do that, we get a new function, of course, called the derivative function. And you can do this using, you can see the limit definition here. There's a lot of work involved to solving something like this. But rather than that, what you're going to do is you're going to be asked to memorize it. So I don't see the little box here. That's okay. The derivative of an exponential function, so if f of x equals b to the x, then the derivative of that equals to ln b times b to the x. Now this is just going to be some number, and of course you have a numerical base. You can never ever combine this number. You can't multiply. Do not multiply. You never ever touch that base. All right, so if I gave you, for instance, let's see, suppose I give you f of x is equal to 2 to the x, then the derivative of that would be what, Dia? Based on the rule. You got this.
Would be
What's the first piece?
the first piece is 2.
No, I mean derivative. So the rule says it's the natural log of b. So what's b here in this function?
B is 2
Right. So the first piece would be ln 2, right?
times 2x.
Times 2 to
2
the
to the
x.
power.
That's right. Good. That's it. That's the derivative. And you leave it like that. You don't put this into your calculator and get a decimal. You just leave it like that. So if I ask the children as a whole, if I say y is equal to 3 to the x, what's the derivative? You all say it's what?
ln 3 times 3x.
Done. Okay, that's it. Now, there's a beauty here. And the beauty is the number e, or the base e. And that's why these exponentials are called b to the x, is because this is called a base and it's a number. So if you have a function e to the x, well, the derivative of e to the x is e to the x itself. That's it. Okay, so if I ask you f of x is equal to 4e to the x, what's the derivative, do you think?
E to the x. No, 4x e to the x.
Yeah, so think of it this way. This is a constant multiple. So, you can think of it as 4 times the derivative of what's left, e to the x, right? And that's just 4 times e to the x, so perfect. Okay, if I say to you y is equal to 1/2 e to the x, what's the derivative? You're going to say it's what?
1/2 e to the x.
Dang, that's right. Okay. So the derivative of e to the x is e to the x, and the derivative of b to the x, b as in Bob, is ln b times b to the x. That's it. Here they are over here. It was under. So this is the formal definition. The derivative of b to the x is ln b times b to the x. Derivative of e to the x is e to the x. E to the x is an extremely special function. Now, let's look at a couple. Let's look at some of the evens and practice a little bit. So for example, Kemuel, can you tell me what the derivative of number 2 is?
This is just going to be e to the second power minus 7e over x since you're doing e over x.
Okay, say it again. I'm sorry. E squared.
Minus 7e to the x.
Okay. Now, this is a number, isn't it? E squared. E's a number, right? If you put e into your calculator, you get 2.8-ish, right? 2.718. So what's the derivative of a number, of a constant?
0.
Good. So what's the answer? What's the derivative here then?
Would it be 2e because use the power rule, or are we just not using that for this instance?
Okay. All right. So look, what's the derivative of x squared? What's the derivative?
2x.
Good. You're an expert. You're exactly right. What's the derivative of 4? What's the derivative?
0.
Good. What's the derivative of 4 squared?
8.
0.
4 squared.
0.
Oh, 0. Because you're
Right.
not, okay, because it's a constant. Okay.
Right. Well, it's a number raised to a power, so that's also a
Oh,
constant.
it's 0.
Right.
Okay.
You got
It's
that?
not a variable.
0, right. So what you said at the end, this part is correct here, right? You got to include the sign.
Yeah.
So the derivative there is just negative 7e to the x.
Okay.
And now you'll never forget that. Good. Good job. Shanique, can you tell me what the derivative of number 4 is? Oops.
So it's 8x to the power of 3
Good.
minus 5e to the x.
Perfect. Perfect. Perfecto. You guys see how easy this is? Zachary, can you tell me what the derivative of number 6 is? Who still has their microphone going? Mute yourself. Zach, are you there? Jonathan, can you tell me what the derivative of number 6 is? Jonathan? Tell you what, guys? Too many of you not answering what I'm asking. These notes go right downstairs to administration, to your parents. Okay? Whatever will be, will be. Rashi, can you tell me what the derivative of 6 would be?
ln 3, or would it be ln 15?
All right, good question. So there's a little trick here, right? So if I were to kind of cover this up and erase it, then what would the derivative of this thing be?
ln 3 times 3 to the x.
Right, it'd be ln 3 times 3 to the x. Now there's a 5 here, right? So you would multiply, you just write it like that. It's 5. So think of it as 5 times the derivative of 3 to the x, which is 5 times ln 3 times 3 to the x. And we just write it as 5 ln 3 times 3 to the x, just like I did above. And one other thing you could do for more compact form, you could use the exponent rule for logarithms and write this as ln 3 to the 5th times 3 to the x. So either way, I would just leave it like this, probably easier. Is that okay?
Okay.
Yeah. Let's see. Mathangi, what's the derivative for number 8?
negative, wait, no. ln 2.7.
Uh-huh.
2.7 to the power t.
Okay, so make sure you put it's ln of the number times the number to the t. Okay, keep going.
And minus 5t to the power 4.
Very nice. Happiness. Scotty, what's the derivative for number 10?
That would be ln pi times x to the pi. Right?
I don't know. Anybody else want to chime in? Thonby, what do you think?
Yeah.
You agree? James, you agree?
No.
No, why not?
Because e to the pi is going to be a constant. So.
This is a constant, okay? E is a number, pi is a number to a number is another number. So this is a big 0 here. And if we want the derivative here, right? Now look, this isn't a number raised, this is not a number raised to a varying x.
Oh, okay.
Careful, okay? So what would it be, Scotty, then?
That would be pi x to about 2.14.
Okay, you just write pi minus 1.
Okay.
Yeah, all right. So pi is a number and we subtract 1, and we usually like to leave our pi's and e's and things intact. So you just subtract 1 from it. You don't use decimals. Good job. All right, here's another trickery. So James, you want to try this one? F prime of x for number 12 here. What do you think the derivative is?
ln 6x.
ln what?
6.
Okay.
ln 6 is going to be a constant, right?
Yeah, but it's multiplied, it's not added or subtracted. Actually, that's, let me interrupt you. This is a good question, all right? And it's, again, I like to differentiate this for kids. Let me see. Suppose you had something like 5 plus 5 to the x. The derivative of that would be ln 5 times 5 to the x. Does everybody agree? Because this is a constant and it becomes a 0, right? And the reason why it's a constant is because it's a number, but it's also a term. It's not being multiplied, it's being added or subtracted to something else. So when that happens, in this case here, you got 2 terms. Here's the first term, here's the second term. So the derivative of that constant term is 0. And then you just take the derivative of what's left. Now, when you have a constant multiple, right, which I discussed last class, something like 5x squared, if I ask you for the derivative, I said you kind of think of you leave the 5 there, you take the derivative of the functional part, and then you multiply the 5 back in, right? So you'd end up with 10x if you use the power rule. So this is a constant which is being multiplied to 6 to the x. So now can you tell me what the derivative would be? This is being multiplied to this. So think of it like this. ln 6 times the derivative with respect to x of 6 to the x. I don't need to take a derivative of a constant that's being multiplied to another function, but I do need to take the derivative of this thing. So what's the derivative of 6 to the x? James. Oscar, can you help him? What's the derivative of 6 to the x?
Shouldn't it just be 0?
No.
No, my bad. Isn't it just conserved as 6 to the x?
I'm sorry, say it again.
I don't really know. as I thought it was 0. So
I think I know Miss Wilson.
Go ahead.
So would it just be ln6 on the outside and then just ln6 times 6 to the x?
Perfect. Okay. So what I want you to see is that, you know, if you look at the original, this is a constant multiple. It's going to stay there. And what you're taking the derivative of is what's in the box, right? Just like I have right here. Here's the constant multiple right here times the derivative of what's left. So you've got your ln6, which was already there, and then the derivative of this by the rule is ln6 times 6 to the x. Well, what's ln6 times ln6?
ln6 squared.
Yeah, it's ln6 quantity squared times 6 to the x, and that is it. Okay? All right? What if I said 3 times 6 to the x? Can you tell me what the derivative of 3 times 6 to the x would be?
So derivative of 6 is x. Yeah.
Right. But there's a 3 there,
Right,
so
and it would be 3 ln6 times 3 6 to the x.
no, times 6 to the x.
Just times 6 to the
Right, the only time you distribute, so if you had 3 times x plus 1, then you know you'd get 3x plus 3, right? You distribute that 3. But with a product, if you have 3 times 2x, you don't distribute, you just multiply the coefficients and multiply by x, so you get 6x, right?
Right.
You do the same thing here. So it would be, what you have here is you don't have 3 ln6 times 3 to the x. You have 3 times the derivative with respect to x of 6 to the x. And that derivative is ln6 times 6 to the x. So you have 3 ln6 times 6 to the x. See that? There's not another 3 multiplied in.
Okay, that confuses me because wouldn't you like going up 1 3 in the parentheses? That looks like you distribute the 3
Not when it's a product. So again,
so you don't distribute when they're multiplied.
right, only when you have sums or differences inside.
Okay, that makes sense.
Is everybody clear with that online?
yes.
All right, how about this one here? Can you guys tell me what the derivative of this would be? Anybody? Give me an idea.
So you would do the
X
natural log of 7 times 7 to the x plus 1.
Can you say it again, please?
The natural log of 7 times 7 to the power of x plus 1.
It's a good try, but no cigar.
Would it be ln 7 plus 1 and then times 7x plus 1?
No. So look, we have b to a variable, right? This is b to a variable plus something, completely different. So do you remember your rules of exponents? How could I rewrite 7 to the x plus 1 power? When the bases are the same, we add the exponents, right?
So it would be like 7 to the power of x times 7 to the power of 1.
There you go. And 7 to the first is just 7, right? So you can rewrite this as 7 times 7 to the x. Now, can you guys find the derivative? Who knows the derivative?
Natural log 7 times 7.
Okay, so 7 ln 7 times what?
7 to the power of x.
7 to the x. Done. You guys see that? What would 16 be? Let's see, Rishi, what would 16 be? What's the derivative?
The natural log of 1/2 times 1/2 to the x.
Yep. Okay. So as you can see, you're going to be doing the odds. And you're going to actually do 1 through 15 odd. I haven't made the assignment yet in Canvas, but I will. All right, so section 4.2 will be 1 through 15 odd. And actually, I'm going to make it 1 through 19 odd. I'm going to change that a little bit. Because I want you to do a little bit of application, like finding the equation of a tangent line. All right. Now we're going to go to section 4.3 if there aren't any questions about these two derivatives here. Anybody have any questions or concerns or anything like that?
No.
Let's go to 4.3 then. The product and the quotient rule. So how I teach these is I go over the rule, I go over a few examples, and then you guys practice. So if you have the product of two functions, the only way you can take the derivative 95% of the time is by using the product rule. Now, there are some functions that are products of one another that you could distribute or something like that. But if you have something like x sine of x, that's a product. It's x times the sine of x, right? You can't distribute or you can't do anything with it, okay? So when that happens, and most of your functions will be of the complex form, then you're going to have to use the product rule. And the product rule says the following. It says the derivative of a product of two functions is equal to the following. You leave the first factor alone, you take the derivative of the second factor, plus you leave the second factor alone times derivative of the first. So kids like to think of it as fig gif. So we say f times g, this is shorthand notation, is equal to fg prime plus gf prime. Okay, so they call it fig because we put a times in between. Well, let me write it like that. Fig plus gif. You take the derivative of the second factor first, multiply it to the original first factor, and then add to that the second factor times the derivative of the first. So let me give you some examples. That way you can see it in action, and then it will make more sense. Let's see. Geometric proofs. Here. Okay. So for example, in number 1a, I have the product of two functions. The first factor is x squared, and the second factor is x cubed minus 1. Now, I could distribute that, right? I could get x to the fifth minus x squared. And then I could take the derivative using the power rule, which if you can do that, I suggest it. I'm just going to add another piece of paper here. Okay, so you can absolutely, unless they tell you they want to see the derivative done by the product rule, then you can absolutely distribute this and rewrite this as x to the fifth minus x squared and then take the derivative, and that's easy. You guys know it's 5x to the fourth minus 2x, right? Easy. But if you wanted to use the power rule, what you first have to do for the grader, and for me, since I am your grader, is write out the rule. So we would say, if this is f of x, we would say that f prime of x equals x squared times x cubed minus 1 prime, meaning I haven't taken the derivative yet, but I'm going to take the derivative of this factor, plus x cubed minus 1 times x squared prime. Again, meaning I haven't taken any derivatives yet, but I'm going to leave this factor alone and take the derivative very soon of the second factor. Is everybody okay with that? So you can think of this as your function f and this as your function g. All right, so you have f g prime plus g f prime. Fig plus gif, if that helps you remember it. So what we have then is x squared. Now what's the derivative of this factor here? Anybody? What's the derivative of this factor?
Would it just be 3x squared?
That's right. Okay, so that derivative's done. Plus, we're going to leave this one alone. And now we have to take the derivative of this factor. What's that derivative?
2x.
2x.
Just be 2x.
Right. So now we can clean it up. And we're going to have 3x to the 4th plus, this one we're going to have to do a little bit of distributing. We're going to have 2x to the 4th minus 2x. And combining like terms, we would have 5x to the 4th minus 2x, just like we got when I distributed a little bit ago and then erased it. The problem is most times you're not going to be able to distribute and use the power rule because the trig functions are coming into play in this section, as you're going to see very shortly. Here's another one. Let's just have some fun. Let's say we've got the function g of x is equal to x times e to the x. Ooh. So by the product rule, what I have is x times e to the x prime plus e to the x times x prime. Again, I'm writing out the rule, right? If you let x be the function f and e to the x be the function g, then what you've got here is f times g prime plus g times f prime, right? Fig plus gif. And if we take the derivative now, well, we've got x times the derivative of e to the x is just e to the x plus e to the x times what's the derivative of x over here? 1. So what we have is x e to the x plus e to the x. And generally, they'll factor out that e to the x and write it as x plus 1. You guys see that?
Yeah.
Are there any questions on that? So, while I'd love to do more examples, we have to wait a bit. Because as you can see, do you see these functions here? Yeah, right? There's lots of stuff going on here. So we got to learn a couple more things, but they're not hard. It's just mostly memorization with the trig functions. So you've got, oh, they're going one by one there. So that's the product rule, all right? And,
This looks a lot like the stuff I memorized last
yeah, it's kind of like the stuff you had to memorize last year. But with the trig functions, the first 3 are super easy to memorize. It's the last 3 that are a little more difficult, but you got to know them by heart, okay? The derivative of the sine is the cosine. In Calc BC, you'll learn why. The derivative of the cosine is the negative sine. The derivative of the tangent is the secant squared of x. So all 3 of these you'll know by the next class. You will know them by heart. And then 2 weeks later when we have a test and I ask you one of these, oh, I forgot. Well, don't. The derivative of the cosecant is the negative cosecant cotangent. The derivative of the secant is the secant tangent. And the derivative of the cotangent is the negative cosecant squared. So if I say to you, Scotty, y is equal to sine of x. What is the derivative of the sine? You're going to tell me it's the?
It'd be cosine of x.
Perfect. Okay? Just by memory. And Thanvi, if I say y is equal to the tangent of x, what is the derivative of y? You're going to tell me it's the?
Secant squared of x.
Perfect. Okay? Now, if I say to you, here's a function.
Wait, Miss Wilson, could you go back for like 5 more seconds? I just want to write down the last one.
1, 2, 3, 4, 5. Done? No, I'm kidding. Go ahead.
Okay. Thank you. Real quick.
Yep.
Okay, done.
All right. So suppose I say to you now, we have this function, which is x sine of x, and I want you to find the derivative. Well, now I've got 2 different functions, right? I've got one function here times this function here, That means I have to use the product rule. And we know that the product rule is you leave the first factor alone, right? So we have x times sine of x prime plus sine of x times x prime, right? And so let's see. Yasu, can you tell me what the derivative of this first term is?
X cosine x.
Good. Now, while you're on the line, why don't you tell me what the derivative of this second term is?
It's, I think that's x cosine x2, right?
No, we're not taking the derivative of this. We're not taking this derivative. We're taking the derivative of x here because the prime is on x. So what's the derivative of x?
1, I
Good.
think.
And 1 times the sine of x would be?
The sine of x.
Right. Very good.
That's the derivative.
That's the derivative of x sine x. It's x cos x plus sine of x. You guys okay?
Yeah.
Good. What if I said, f of x is equal to e to the x tangent of x. I have a product, right? I have one factor here and one factor here, and they're being multiplied. That's my cue to use the product rule. So that means I have to write out my rule first. It's going to be e to the x times tan x prime plus tan x times e to the x prime, right? So what I want to know from everybody right now, and I don't want to just hear from one person, is this okay, writing out the rule? Is everybody understanding how to write out the rule?
Yeah.
Yes.
Yeah.
Yes.
Yes.
Good. So, Shri, can you tell me what the derivative of this first term would be then?
So it would be secant squared, or e to the power of x, secant squared x.
Good. Keep going. What's the next one?
That, okay, so that would be tan x. Would this be the ln x?
No, the derivative of e to the x is e to the x itself.
LOL, I remember that.
So nothing changes there, right?
Mm-hmm.
And if we factored this out, we'd end up with secant squared of x plus tangent of x. And we're done.
Wait, Ms. Wilson, I'm a little confused about how the second part of the derivative function, the tan x and then to the e x part. Yeah, that part. I'm confused as to how that it stays as tan x. Wouldn't it change to secant squared x?
No. Okay, so here's why. And this is a good question that you're raising, and probably there are others who are a little confused too, so I'm glad you asked it. When we use the product rule, I want you to notice from this formula right here that we leave one factor alone and we take the derivative of the other in the first term. You with me on that? Yeah. So here I'm leaving e to the x alone, but this prime mark means I'm going to take the derivative of this factor. And then we add to that, then we leave this factor alone because we already took its derivative over here.
Oh, okay.
You see?
Okay.
So we're kind of flipping them after the plus sign.
So we're not taking the derivative of both, just the...
No, I didn't take the derivative of the tangent. I'm taking the derivative of e to the x on this one because I didn't take it over here.
Okay.
Is that okay?
That makes more sense. Yep. Thank you.
Yep.
Does the prime, like the prime sign, act as like kind of like an exponent, you know? Like if that was like a squared or something, it would only apply to the tangent x. So you have to have, no,
the prime marks, or the tick marks we call them. Those are placeholder. You can think of it as a placeholder. It's not a it's never a number. So like over here, when I say f prime, it does mean first derivative of f, but this mark means we're going to take a derivative. And so what I'm telling the grader is, I'm not taking the derivative of this, I'm taking the derivative of this term. And it says, I'm not taking the derivative of this grader, but I'm taking the derivative of this term. So you can think of it sort of as a derivative marker, I guess, meaning I'm going to take the derivative of what's inside the parentheses here, and I'm going to take the derivative of what's inside the parentheses here. I just haven't taken the derivative yet. I took the derivative in this line. Is that okay?
Yes.
Let's do another one. F of x equals 2 sine of x. I have a product, or do I not have a product? I have a product, right? Now, technically speaking, I could use the product rule. So let's just use it. I don't have to, though, because this is a constant multiple, but let's just use it. The rule says I leave the first factor alone and I take the derivative of the second. So I haven't taken the derivative of the sine yet. I'm just telling the grader with that mark that, hey, lady or guy, I'm going to be taking the derivative of this factor. This product contains two factors. 2 is a factor and the sine of x is a factor. So you take the derivative of, you leave one of them alone and you take the derivative of the second, and then you add to that, you leave the one that you took the derivative of alone and take the derivative of the one that you didn't last time. It's hard to say, but does that make sense? So again, in this first term, I'm leaving the 2 alone, but I want to take the derivative of the sine function. And in this term, I want to leave the sine function alone because I'm taking its derivative over here, and I'm going to take the derivative of the one that I didn't in the other term, or the 2. So I'm kind of swapping the derivative. I'm kind of swapping which ones I'm taking derivatives of. Yes, no?
Can you say that one more time, please?
Yeah. Okay. So again, I'm not taking any derivatives here. I'm just writing out the rule, okay? I'm showing the grader that I understand that 2 times sine of x is a product of 2 functions. 2 is its own function and sine of x is its own function. Is that okay? And when you have a product of anything, I don't want to call them terms because they're not terms. Terms are separated by pluses or minuses, but each piece that's being multiplied is called a factor. So this is a factor and this is a factor, okay? And together they form a product. So what I'm writing in the rule is I'm going to leave the 2 alone and I'm going to take the derivative of the sine function. Plus, now I'm going to leave the sine function alone and take the derivative of the 2. So in this term, I'm taking the derivative of the sine function. And in this term, I'm taking the derivative of the 2. So each term contains the derivative of one of the factors. No?
Yeah, I just zoned out. My bad.
No, it's okay. So let's just finish this derivative and we'll do some more practice. So so remember, if I'm going to take the derivative now, I'm not touching the 2, but what's the derivative of the sine?
Cosine.
Yeah. Plus, so I'm just bringing this down. Now I'm leaving the sine of x alone, and I'm taking the derivative of 2. Well, what's the derivative of 2?
0.
0. And 0 times the sine is 0, right? So my derivative is 2 cosine of x. Now, I could have done 2 times the derivative of the sine, and I would in real life. And because this is a constant multiple. So I'd say, oh, that's 2. What's the derivative of the sine? Oh, it's the cosine, and be done. Okay, I wouldn't go through all this work for something like that. But I was trying to prove a point. So let me find something with different factors. So they're clearly, how about y is equal to 3x times x squared plus 1. Now, I know you can distribute and use the power rule, right? If I distribute this, I'm going to get 3x cubed plus 3x, and then the derivative is a cakewalk, right? It's 9x squared plus 3. But what I want you to do is use the power rule so we can practice, or not the power rule, the product rule, so we can practice it and so you can see the difference. So I would say y prime is equal to, I'm going to leave the first factor alone. Again, it's a product. It's this times this. So I'm going to leave this first factor alone, and I'm telling the grader, but I want to take the derivative of that second one. So I put a tick mark there. Okay. And then the rule says then you add a plus sign, and then you leave the second factor alone. So I'm telling the grader, hey, I don't want to take the derivative of this term, but I do want to take the derivative of the other, not the term, rather the factor. Okay, so you notice in this first term here, I'm leaving the first factor alone, and I'm telling the grader I want to take the derivative of the second factor. And then after the plus sign, I'm telling the grader now I want to leave that second factor alone, and I want to take the derivative of the first. In this term, the 3x is being left alone, and in this term, it's being, the derivative is going to be taken. In this term, the x squared plus 1 is going to have a derivative in a minute, and in this term, it does not. Yes, no?
Yes.
Okay. So with that being said, now I'm going to take the derivative. So I'm not touching this, so I'm bringing it down, right? And somebody tell me what the derivative of this factor is.
2x.
2x, right. Okay, now I'm going to bring the plus sign down. Now we're leaving this thing alone, but we need to take the derivative of this one, right? And what's that derivative?
3.
3. Okay, so now if I clean this up, I'm going to have 6x squared plus 3x squared plus 3. Do you agree if I distribute that? And that's going to be 9x squared plus 3. So clearly, using the product rule was the long way to get to the derivative, because you saw if I distributed, I got it in 2 seconds. But in most cases, you're not going to be able to distribute. And what I want you to see is that you're taking the derivative in one term. Terms are separated by pluses or minuses. So this is a term and this is another term. In the first term, we're taking the derivative of this factor. And in this term, we're taking the derivative of the other factor. Huh? F of x is equal to 4x cos of x. Let's just make it x cos of x. So the product rule says I'm going to leave the first term alone and take the derivative of the second. And I'm going to add to that the second factor times the derivative of the first. Is everybody okay with me writing out the rule?
Yeah.
Okay, so now let's take the derivative. We've got x times, what's the derivative of the cosine? Go ahead, James.
Negative sign.
Negative sine of x. Good. And what's the derivative of x in this term? 1. So we would remember that multiplication is commutative. So it doesn't matter if I write x times -1 times the sine of x, or sine of x times -1 times x. We just bring the sign out and we're done. So now I'm going to give one for all of you to do without any help.
Actually, I have a question.
What?
So some of our questions had us, plugging in numbers, and that we would use our calculator, right?
Sometimes, but most of the time, if they're unit circle values, then no, you would not use a calculator.
Oh, so like on a test, we have unit circle values.
Mm-hmm. So they'll give you pi over 3, pi over 6, pi over 2, those kind of values that are commonly known, that they expect you to know. And that would be, no, we're beyond the unit circle quiz in calculus, but that's why I gave like 6 of them last year, or I wanted to give more, but we had COVID. So yeah, I couldn't stress enough the importance of the unit circle and knowing all of those values. So anyway, yeah, no, they will use unit circle values, and then you would be expected to know how to do it without a calculator. So Let's see. This is the one you're going to try. So f of x is equal to x squared times e to the x. And I want you to find f prime of x. And I'm not helping you. I'm going to read my emails. Let me know when you have an answer, even if you think it's wrong.
X squared e to the x.
I'm sorry?
2x squared e to the x.
Okay, so somebody's saying the derivative is 2x squared e to the x. So we don't know yet, maybe. I want to hear from a few others to see. What you come up with.
2x times e to the x.
So 2x times e to the x.
Oh, no, yeah.
Yeah, what?
That one makes more sense.
This one? Okay.
Yeah.
I got 2x plus e dx.
Okay, there's another one. Thank God mathematics is an exact science. Imagine all the answers I have.
I got 2x times ex plus ex.
Okay.
I got dx times in parentheses x squared plus 2x.
Like this?
Yeah.
Okay. Anybody else want to chime in? Should we do it or should I wait a minute? People, the crystal ball is at home and I cannot read your minds. Neha, what did you get? Shashank, what did you get?
Miss Wilson, Neha's mic isn't working.
Is she on the chat?
Yeah, she's gonna type it in. Oh, she sent it.
Yeah, I see it. Okay. All right, so let's do it then and see which answer is correct. So so this is my function. By the product rule, I have to say, leave the first factor alone times derivative of the second factor, plus leave the second factor alone, and we want the derivative of the first, right? You must write that statement. And then, now I'm going to take the derivative. So we've got x squared, and the derivative of e to the x is e to the x, plus, now we're leaving this alone, and the derivative of of x squared is 2x, right? So this is x squared e to the x plus 2x e to the x. And if we factor out an x e to the x, we're left with x plus 2. Yes, no, did anybody get to this piece here, to this part?
Yeah, it's just a simplified thing of what Gabriel
Good.
said.
Right. So if you got this far, you're doing great.
That's where I got that.
Yeah, and that's fine. Yeah, some of you may have just factored out e to the x and ended up with this one here. So what concerned me with, let's see, these two is that right away I noticed there wasn't a plus sign in between them. All right, and so generally, not to say it couldn't happen, it's rare, but with the product rule, normally you're going to see a plus sign in your final answer. All right, so it looked like here somebody took the derivative of this and multiplied it to e to the x, but didn't finish the problem. All right, and well, actually there wouldn't be a square there on the x, but and then this one looks like did 2x times e to the x, and again didn't do plus x squared times e to the x. So you're only doing half the problem here. So be careful with that. Write out the rule first. This is step number 1. Write out your product rule mathematically. Then take the derivative. Step 2 is the derivative, the actual derivative. And then step 3 is clean it up. Okay? Clean it up. So I think I'm not going to go over quotient rule because that's a little more difficult. What I'm going to do, let's see. So those problems that I'm assigning, I can find them. Where are they? Oh, geez, you don't want to do the chain rule. Heck no. No chain rule for you. 4.4, what is going on here? Am I in like the wrong section? Oh, no, it's both sections. I'm sorry. I forgot that it's all in one PDF. It's up here. I think what I'm going to have you do is you're going to actually do 1 through 9, because as you can see, this is a product rule, this is a product rule, this is not a product rule. But then we've got some quotients here. So I'm going to have you do 1 through 9 odd. No, let me take that back. I'm going to have you do 1 through 10 all. Because if you notice, you're dealing with product rule, you're dealing with exponential functions, and you're dealing with the trig functions. B to the x is the same as e to the x, except for the, and by the way, you know, it should be noted that if the derivative of b to the x is ln b times b to the x, well, e to the x is ln e times e to the x, but what is ln e? What's the natural log of e? People.
1.
1. And what's 1 times e to the x?
EX.
Yeah, so
32.
that's right. That's why the derivative of e to the x is e to the x, okay? Any other base will have, you know, that ln2, ln3, whatever it is, okay, in front of it. But ln e is 1, and so that's why the derivative of ln e is, or sorry, e to the x is e to the x. So it's the same thing, all right, whether it's e or 3 or 5 or whatever. It's just that this is a special function. So you're going to do 1 through 10 all, and that'll be due on Tuesday. And at which time you're going to have a quiz. So don't forget, I'll do it in red. You're going to have a quiz on Tuesday. And that's going to encompass section 4.1 and maybe a bonus from 4.2 or 4. So maybe a product rule bonus, or, you know, extra, not extra credit, but a bonus question at the very beginning of class. So don't be late, because I would hate to give zeros. All right. Anyway, you've got 10 minutes. So you might as well get a head start. And that way, if you have any questions, you can ask me. In the meantime, I'm going to go to Canvas and put this assignment in. Especially for you, and we'll do quotient rule next time. I don't want to overwhelm you. I know I gave you a lot of information. A lot of good information. All right, grade book, block 1. Block 1. Tuesday, wow, Tuesday is the 13th already.
Ready for the weekend.
Me too.
So I'm sorry, 1.10, that's in 4 point.
1 through 10 all in 4.3. I'm skipping work in 4.2 because you're going to see it over and over with quotients and products, so you'll get the practice there. All right, so the, make sure my microphone's still on. Yeah. The section 4.3 homework has been posted under chapter 4 homework in Canvas. Rohit has an excused absence. Goodness, there's so many family emergencies when homework is due. I've never seen anything like it. The amount of family emergencies has been astounding.
My friend went to the Appalachian Mountains and still gets homework done. And that's one of my teachers was saying, he's in the Appalachian Mountains getting his homework done.
Right.
People are at home doing nothing.
Right. No, it's true. There are many students who go on vacation, whatever, and they do their homework and submit it. Now that we're online, it doesn't matter where you are in the world, you can submit your homework. But these students are not in the Appalachian Mountains. They're here, but they all have family emergencies or all of their internets go out. It's the same kids over and over. It's an easy target. And I'm not saying that some of those family emergencies aren't legitimate, because I'm sure there are some legitimate family emergencies. But the extent to which you get that excuse is undeniable. Clearly, it's in many cases just another excuse. And excuses don't work in colleges. In college classes, if your work's not there, you get a 0. There's no whining, there's no asking, there's no begging, it doesn't matter.
I should mention that because there's this post that circulated around somehow teachers always say that college professors won't take any of those excuses, but there's this one girl who was like eating a meatball sub while taking a test, and a meatball fell on her keyboard and submitted the test before she was ready. She got like a 30% on it, so she asked for a retake and gave it.
She's lucky, but
He said it's due to the bizarre nature of your excuse.
well, probably because, right, and you know why? Because she probably got maybe a little more than 30% when she actually did submit the test. That's normally how it works. So it's always the kids who this happened, that happened, and they have, I mean, you have to admit, she had creativity. So that's probably why he gave it to her. But the cleverness is in his action, because by letting her retake it, you know, kids think that if they take one more day out and study that they're going to do better on the test. They don't. It's a statistical fact. They don't. So maybe, you know, the meatball gave her a 30% on her test, but when she actually went in the next day or something to take the full test, maybe she got like a 60%. So maybe instead of getting an F, she got a D. But that's the nature of the beast. That's how it is. It never fails. It doesn't matter whether the kid's in high school or college. We know. We're not stupid. But y'all sure think we are. Boy, you guys have a lot to learn. Especially math people, because most of us, not all of us, but most of us are very, very smart. We know. I forgot who said it, but they said, a famous mathematician said, Something about running circles around math. You can't run circles around a mathematician. It's true. My husband just hits the delete key. Dear Dr. Sheckman, you know, so-and-so died. Delete. It's in your syllabus. If somebody dies, if somebody gets married, if you're going on a cruise, and you miss my test, you're getting a 0. End of the story. Well, we're not in college yet. It doesn't matter. It's a college level course. And one of the chair people at USF, he's like, he does not take crap from any student. He just, he sits there and he smiles and he nods and everything, and then he rips into them until they walk away with their tail between their legs. They don't ever go back and say anything to him. He's the chair at USF, and he's like, I can't take it. He goes, these kids are, you know, trying to BS me. And so he lets them go on with their spiel, and then he lets them have it, and he battles them with logic, and it leaves them speechless and realizing how stupid it was that they tried to do that. So be careful who you whine to. Don't mess with the mathematicians, and don't mess with the people in the hard sciences. So like physics, bioengineering, those kind of sciences, because those are smart people. I mean, smart people. And who?
Mrs. Jacobson was her name.
What did she teach?
Physics.
Physics here?
Yes.
Oh, well, because it's
I'm not
here.
sure if she's still
No, I'm
here.
talking about at university level.
Oh, university.
Yeah. Yeah.
But my AP Gov teacher taught at university level, and he is super chill.
No. They all are. And the funny thing is there are some teachers here who walk around saying, well, you know, I have 2 master's degree, you know, boasting about their degrees and stuff. And I'm like, you know, me and another teacher were discussing that behavior, and we're like, a true person of knowledge, of high intellect, they don't brag about anything like that. And if any of you ever come to my house over Thanksgiving or Christmas, when we have a house full of mathematicians, they're all very chill because they all have very nice jobs. They're very mellow, but if you try to mess with them or challenge them intellectually, they're going to put you in your place, and you're going to be embarrassed for yourself. Trust me. So, no, very nice, very chill people, and very humble acting. They will never brag about, because there's nothing to brag about. People who have the true thing going on don't need to brag about it. Just remember that. All right, you guys online, the bell's about to ring, so you can go. I hope you have a fabulous weekend. And make sure you study your basic derivative rules, because you're going to have a monster of a quiz on Tuesday.
Bye.
Bye. Be good.
Have a good day.
Bye.
Bye, Miss Wilson. Have a nice day.
Derive. Don't drink and derive. I should put that.
I got number 1 right away. It was fairly
This
easy.
one? Yeah.
Number 2 stumped me. I know I only looked at it for like 10 minutes,
Mhm.
but number 2
It's
just
2x sine of x plus x squared plus 1 times cosine of x.
what?
So the derivative of the first term would be x squared plus.
It's actually not on there, but number 2 right above it.
Oh.
Because you said do the evens as well, and that one stumped me.
Oh yeah, I'm sorry, I meant 3 through 10, but that's okay. Oh yeah, good. Let it, keep thinking about that one. It's actually really easy. It's easy, but keep thinking about it. Do the rest and then go back and try it again. But don't rack your brain over it. You'll see how easy it is next time.
All right. Thank you.
You too.